Hello, everybody. This is Sarah Colada with Architecture Talk Tongue, back the second time today with an amazing guest, Oliver David Krieg, who actually is going to talk to us about a real disruption he's working on under a company called Intelligent City, which is an architecture company. They're using high-tech technology to design high-rise mass timber urban housing with the use of parametric design, computational design, and we'll talk a little bit about what sort of technologies really you need to use in order for a company like that to emerge in the first place. We'll talk a little bit about Oliver's journey as an architect and computational designer, and about the technologies that actually you can tap into as an architect to create real disruptive innovation. So, Oliver, thank you so much for joining me today in Architecture Talk Time.
Thank you so much for the invite. It's a pleasure to be here.
Yeah, it really is. So, we wanted to know a little bit more about you. So, perhaps you tell us a little bit about your journey and what got you to, first and foremost, actually work on computational design.
Yeah, for sure. I think like many people that are probably listening to your podcast or that are working in the architecture industry and have sort of diverted a little bit into computational design, software development, programming, and maybe even robotics. I too studied architecture, but I never ended up registering as an architect. I pretty early on realized that there are all sorts of possibilities to combine software development or just computational design methods with the actual design of buildings and also with manufacturing or fabrication technologies such as the industrial robot. So I'm a real child of that early 2000s, the first the 2000 to 2010, the first 10 years of the century, where lots of professors and institutions were founded that have robots in their labs, and they try to experiment with that a little bit. So I got stuck with that. I did a PhD in robotic fabrication in timber construction. For architecture, so with the idea of like what impact it can have on architecture and design. And then in 2017, 18, I got in touch with Oliver Lang, and Cindy Wilson, who are the co-founders of Intelligent City. And until then, for me, it was I think again this is a very common occurrence for people who have sort of dove into computational design and who understand that there is a possibility to automate and systematize the way we design buildings. Many people might have gotten stuck in architecture firms that have a very small team of computational designers, and they like to use them for projects, but it's very difficult to really build some kind of platform that really everyone can use. And I was in academia for a very long time before then, and so for me, I had a lot of freedom in what kind of systems and processes we could design and come up with. And so I never really thought I would go into the sort of the real architecture world. But when Oliver Lang and Cindy Wilson approached me, they talked about this idea of how all of that could actually be used to as a foundation for a company to productize housing. That's when I realized, okay, that all of this stuff that has been developed and experimented with for maybe decades could actually be applied in the real world. And that's when I made the transition and joined Intelligent City as the chief technology officer.
That's amazing because it really gave you an opportunity to make a mark and really see how that sort of experimentation and parametricism and design technology can be adapted and reflected in a real life scenario. And in this case, actually, you guys are working with quite an unusual material because, a lot of times with fabrication, in digital technology, we find perhaps more moldable materials, that are easier to create units out of and perhaps multiply. Timber is also wood allows for it, but in some way, of course, it has its own parameters as well that you work with. So it's really interesting that you're taking that material to high rise. Tell me a little bit more about that process.
Yeah, it's a very good point. And maybe if you just sort of looked at all the available building materials that are out there, you'd wonder why necessarily with all the innovation that we are doing, we are also burdening ourselves with another sort of innovation in some way, because mass timber just hasn't been used that much, even though we know it's possible to use it in high-rise construction. There are very few buildings that really have showcased that. But I wouldn't do it any other way. We are developing. We're not just an architecture firm. We are also we're basically integrated company that does everything from design to manufacturing of buildings, and we're not doing the on-site work at the moment. But basically, it's a design to production sort of company scenario that's vertically integrated. And so for us, when we thought about or honestly, when the founders thought about how to set up a company that productizes buildings, that really thinks about what kind of designs can we achieve, how can we make them, and how can we put them on site and assemble them really quickly, and then also keep all of that as flexible as possible so that we can accommodate a wide variety of designs. Already 10 years ago, they thought that it has to be mass timber, because it's the only building material that is somewhat sustainable and that is available, at least in North America and in Europe, enough to be used for a large quantity of housing construction. But it's also material that is very easy to use. Right? If you think about all this effort to make these building systems and prefab them and have factories, and then you're using concrete, it would be way too heavy to transport anywhere. Steel is somewhat doable, but I'd also argue it's very difficult to work with. The fabrication environment is a lot more hazardous than wood, and of course also more difficult, right? And still heavier. So it's really the ideal material to use in prefab and sort of build your whole technology around, because it has the right size and weight to employ automation equipment like industrial robots, and it's easy to cut and process, right? So it's very easy to parametrize and change the sizing and the combination of those parts. And ultimately, if we want to achieve a sustainable urban future where we have mid to high-rise buildings that are carbon neutral, both in their embodied carbon and their life cycle carbon, then there isn't really much of a choice, I would argue as well, even though I know that using mass timber on a large scale can have implications, and we're confident that we can understand them. But it is really just sort of, it goes really hand in hand, and you end up with buildings that are extremely beautiful on top of that, because you can actually use the material also in the interiors, and you can really have a very holistic approach to how to design high quality, well performing buildings.
This is so fascinating. So we talked a little bit about the sort of technology as well as the choice of material, but tell us a little bit more about the project itself. Who does it service, and what is sort of the larger scale implication of it?
Yeah, so you kind of have to put in sort of all the puzzle pieces to make sense of our company, even though I would argue it's actually not so much it's not so difficult. If you think about in any other industry, when you develop a product, you think about what's the market, what are the design choices, how is it made, what are the materials, how do I produce it? So you develop, you design, the engineering, the manufacturing, and the distribution of it, right? And so whether you buy a laptop, a phone, or a car, or a plane, there it's the same kind of process. It's pre-engineered. You know what you're getting. It's all finished, right? You can look at it, and then you can order one, and maybe you have some customization opportunity. Now, the biggest challenge, and why maybe we haven't seen this so much in our industry, is because the level of customization is just almost impossible to grasp in our industry, right? Every building is different, needs to be different. The owners want it to be different. The jurisdictions require some difference, right? Whether it's we are in Vancouver, so when you go to Toronto, you don't have seismic loads, so then you have to change things again. So there's a lot of different levels of customization. I would call it hyper customization, because there isn't really the term mass customization that we know from the car industry doesn't even serve it justice. So you really need to develop a fundamental understanding of possible permutations of the system to really make sense for it to be developed upfront and then applied. So when you think about it as a product, it kind of makes sense that you have to determine what it is, where it's supposed to go, and what is the possible variation. So for us, we saw the need for urban densification. So we're talking about mid to high rise, 3-4 stories, up to 15, maybe 18 stories. Honestly, much higher isn't even needed. It's just sort of a nature of concrete construction and sort of, downtown centers that kind of want 40, 50, 60-story buildings. That's fine, but the vast majority of our cities would benefit immensely if we just build 6, 8, 10, 12-story buildings. And we see the need for that in Vancouver and Toronto, or everywhere. It's popping up in all of North America and in Germany as well, and other European countries. So there's a huge need for this sort of mid to high rise construction, which is in some cases goes into the high rise construction. So you need that level of engineering, and mass timber is very well suited, especially for sort of the 12-story, sort of the sweet spot, we say. So we developed the building systems around that. We developed apartment typologies and design typologies around that, or we still are. So basically building a catalog of offerings, what kind of typology of building you want, what kind of apartments you want to put in there. And ultimately, this will end up being a really big configurator, like a car configurator, just a little bit more complicated and more variable than you would normally see, because you have a 33-foot site or a 99-foot site or a 150-foot site. It always changes, of course. So that's the kind of the product that we are offering. And as we're developing it, we are talking to clients, and we are developing sort of the different typologies depending on what we see, what is really needed. Both currently we have a very strong market in Toronto and in Vancouver, so we're really seeing those two cities as our market entry points. And we have a handful of projects right now that are pretty close to going into construction. And I would say the really sort of the sweet spot is the sort of 9 to 12-story urban residential with a commercial base, and usually passive house performance, so really well insulated. And basically from the ground slab up, you have mass timber, you have only concrete for the foundation and in the underground. So these are the kinds of buildings that seem to really make sense in our cities to densify. And the combination of commercial and residential also is really important, so that transition, the structural system for that has to be developed. And so basically we're just collecting all these bits and pieces of information. We also think about how to manufacture those building components. So the slabs and the columns and the outer walls, the facade panels, everything is panelized. So we prefabricate all of that and bring it on site as a kit. And then you just basically, once you have the concrete in place, the building goes up super fast. And then you handle the interiors on site again, although I think there's lots of potential to also expand that into more prefabricated components. Basically, you have a full kit of parts, bathroom parts, kitchens, interior walls, and everything just comes on site prefabricated, and you just assemble it really quickly. So that's kind of what we're aiming for, and we are seeing lots of interest in that sort of scale, usually 30, 50, 100 apartment in a single building. And we are adapting our designs and sort of our product in a way towards what developers really need and want, right? Because we have to accommodate their design vision as well. So it's a B2B business, but it's also with the users, with the tenants or the owners, the future owners in mind, really to be able to offer something that's really high quality, but also accommodates the vision of the developer.
This is so interesting on so many levels. I mean, something that speaks to me personally is the fact that actually this building is natural. I kind of can imagine that the ambience of living in it is completely different than in the normal high-rise buildings built around. So that's kind of really great for like a conscious developing city, communities as well. I'm guessing in Vancouver, there's a lot of people that are kind of sustainably minded, already into their recycle and maybe organic food and again, like local produce, things like that. So I think that that's just a perfect client for it. But tell me how the relationship with the developers evolves. Is this indeed a project that developers are getting excited about, or is there any type of obstacles they find, maybe cost wise, or I mean, I'm imagining that since the project gets delivered pretty quickly, that's definitely a plus for developers to be able to just streamline through the construction that usually takes a lot of time, and there's a lot of unpredictable issues that can come with it. Being able to bring a plug and play design on site, that convinces me, certainly, if I'm building a larger development. But tell me a little bit about that relationship with developers in the first place.
Yeah, that's a very good question. And I think you kind of put the finger into the wound. It is just innovation in our industry is difficult, and I wouldn't even blame developers or anyone in particular to be at fault. I understand when you're spending 20, 30, 40 million dollars on a project, you don't want to take unknown risks. You don't want to make mistakes, right? Because one mistake, one wrong project, and you can basically close your doors, right? So you have to be very careful, and I totally appreciate that. And that's what we're trying to do. And we're not trying to reinvent the wheel, really, but there are some fundamental things that have to change when you engage in a more productized development. So when developers come to us, they have to understand, and we're educating them that when you do, actually, to be honest, when you do mass timber in general, you have to change your thinking a little bit already, even if it's on-site built mass timber, because the grids and sort of where the columns are is a little bit, or needs to be a little bit more rigorous. And so you are a little bit more restricted in your design freedom. I think generally, the typical design process for a developer is they go to an architect to get a feasibility study, and they really just look at the layouts of apartments and how many they can squeeze into a building, and structure, material doesn't matter at all, right? So they come up with any sort of plan layout, and that's fundamentally the wrong starting point, because if you from the beginning ignore any kind of materialization or any structure, then you will end up having issues down the road. So you have to start with a more rigorous process. And that's the cool thing about what we are offering, is that whatever we design is buildable. It's immediately buildable, in fact. If there were no permitting processes or any design changes on the line, we could basically press a button and the whole thing gets automatically generated and we are ready for manufacturing in just the same afternoon. But there is, of course, a more rigorous design process needed, and you have to sort of fine-tune the design as well. But it's all based on a system. And so we have to kind of go in and explain and show that, if you're more rigorous and you follow a design system, basically, then you get, very good apartments, but most importantly, you get everything already pre-engineered and there's no risk anymore. But you do have to change the thinking in the beginning, and then in the end, you get a lot better of a product, right? And so, it's the same with any other product. Again, we tell some developers, if you order a BMW, you don't go into the factory while it's being built and you ask them to change the doors, because that's not possible. But in return, when you order the car, you know exactly what you're getting, and you know it's going to be good quality, right? So that's just a little bit of a change in how things are made. And so that perception of risk, that just requires a bit of an education, and a rethinking. So ultimately, the biggest challenge for us is getting buildings built to prove the concept, right? And to prove that this works. Because from a cost perspective, otherwise, it has no implications. If you swap out concrete with wood, it is all the same. The only reason why you would see an upcharge is because trades and contractors are also not used to it. And so they are afraid, and so they add another 10 or 20% because they don't know what's going to happen. So you have to take them along. You have to integrate the teams, the trades, the consultants, and take them from the beginning. And then your building is faster in construction. You do reduce it by a third generally, because on site you can basically build the whole superstructure. We did one 4-story building many years ago that was built in 36 hours, right? So like all the disruption and all of these things, they're getting reduced. You can basically have revenue faster.
Yeah,
So
and also the neighbors are not getting annoyed with the building. That's horrible.
exactly, especially in urban environments, it's really important,
Yeah.
right? We have lots of electricity lines for the buses in Vancouver, so you need to take those off. And if you only do this for 2 weeks instead of 4 months, that's a huge advantage as well. So lots of advantages come, but you have to sort of commit to the process, and that's maybe the biggest challenge.
So actually, I'm quite impressed by the way that you were expressing it all in a very eloquent way. You're selling me onto that idea, and I think it comes from the confidence in the product and also working on it to basically prove the point and do it over and over again, where you see that it works economically, it works from the perspective of habitation and also quick delivery, etc. But what I really wanted to emphasize and maybe kind of get into a little bit more is the whole sales system. How do you take a potential customer, whether it's a developer or an investor or whoever wants to be involved with this, on that journey of convincing them or showing them to think differently about that project? The BMW example was magnificent, but you spoke a little bit about education. I wanted to kind of go there. Do you guys have, I don't know, any type of educational material, or is it all basically you onboarding the client really well and explaining it and talking about those benefits? How did you evolve the business around that part, which I think is quite crucial in your sales process?
It is, and I think you said the right thing. I think educational material is important. We don't have that yet. I think that's definitely something we need to develop. We need to develop brochures and videos that explain these processes, and it has to be a very clear and upfront, sort of transparent process, I think, as well. Developers usually have a couple or a handful of architects they like to work with. And sometimes they use an architect to do a feasibility study or to do rezoning, and then they go with a different architect afterwards. And that's usually not an issue because all architects are used to working the same way, right? So again, we need to kind of explain them, well, if you go with us, you can, if you want to, you can still cancel the contract halfway through and go with another architect and build it out of concrete. Hell, what do we care? It's possible, right? It doesn't make sense, right? It's difficult to just then take the whole thing and make it out of concrete. So again, you kind of have to commit up front, but the return is very, very positive, and that needs proof, of course. So what do you do when you buy a very expensive car or a house? You go and you look at it. You kind of you test drive it, right? There's a step-by-step process, and we need that step-by-step process as well. So when a developer comes to us, we of course we present everything we're doing, and we explain them the benefits of using mass timber and using our systems, and then we kind of we lay it out and we take it step by step, right? Ultimately, yes, you will engage in a typical contractual relationship like you would with an architect. It's just a more high-level contract. We have our own architects, but we're also managing the entire project. And by finishing that design and planning process, we earn the right to then also deliver the building components. But it all starts with a conversation, feasibility studies, and because we have our own software that uses those systems that we have developed, it's very easy for us to go through iterations and showcase sort of different variations and possibilities, and they're all within our system, so they're all buildable, right? So we can kind of show, here's an 8-story, a 6-story version. This is how much it'll cost because it's all connected to our own internal database. So it's just very easy for a developer to understand the potentials and the benefits, right? It's a bit of a test fit software, but based on our systems. And so it comes with all the information that you have in a fully finished building system. You can see all the quantities and all the cost of it. So, but you have to take them along, and you can't ask someone to come to you and sign a contract for $40 million, right? You kind of need to take it step by step and give options to leave if it doesn't work out. But if it does work out, they understand what the benefits will be.
I love this. And I think that all of that stuff that you're talking about is extremely important, especially if you're doing something a little bit outside of the grid or of how things are, outside of the system, outside of the norm. Let's deep dive into technology again. I know that that's your passion. And, my question is, what sort of technology needs to exist for companies like yours, like Intelligent City, to emerge in the first place?
Yeah, that's a very good question. Because you could argue that prefab has existed for decades or centuries. Actually, catalog homes have existed for a very long time, but it never seemed to be of any advantage to conventional on-site construction. So I think there's two things that we needed that had to mature, two technologies, and one of them many are very familiar with it. That is computational design. And what I mean with that is, if you want to develop and pre-engineer a building completely, basically, to all the detail that you needed to build it, that effort to do it up front and then only build the building once really doesn't make sense, right? So you need to be able to build it, dozens or hundreds of times to make sense of that pre-engineering. But of course, you cannot build the same building over and over again, especially in multifamily high-rise. You probably wouldn't even find a lot that fits, aside from the fact that a different developer doesn't want the same building that someone else has already built, and a different jurisdiction probably doesn't allow it either. So you need that flexibility. And the concept of computational design and parametrics is that you're not defining building parts by their direct values. You're defining them by a range of values. That's why it's called a parameter, right? You're defining them by parameters. So a floor panel or an envelope panel or a column can have a location and a size, but what the location and the size really is, that's a range that can be, from X to Y. And so if you define everything by its ranges and you define everything by its rules or rule sets, then you have a parametric system, right? So we develop our building systems by using this kind of concept. We're defining, what kind of spans can you accommodate, what kind of grid spacing can you accommodate, how do you subdivide a facade into panels that can be transported, what are the rules, like how do the facade panels go around the corner or around the zigzag, how do you attach balconies. All of these things are rules, and they are basically written down literally, and then they are put into software. And then when you design a building and you say here's a balcony and here's a corner, then it fills up that design intent with the actual geometry. So it's a huge parametric system. So that's the one thing we have to think about. everything in terms of parameters and not in terms of fixed values or fixed solutions, because then you get stuck with standardization, and standardization usually will make things very difficult, especially if you have so many different clients. And the other technology that we need is basically, I like to call it parametric manufacturing. It's the equivalent, but instead of moving bits, you're moving atoms, and you're doing it in the same logic. You need the flexibility in your manufacturing process. Again, lots of typical manufacturing processes, even when you are in the realm of mass customization and Industry 4.0, it's still usually based on standards, right? And you just have 12 standards or 24 standards. And when you have 12 by 12 by 12 different options in a product, you do have a lot of options. So it kind of feels like it's completely customizable, but usually where things get really difficult is when you change the shape. Cars don't change the shape, right? You can only order one Golf and one BMW 3 Series, and you cannot change the size and the width of the car. But in our industry, you need to. So you need the ability in the manufacturing process to accommodate that design variety. And so that's where parametric or adaptable manufacturing comes in. So that means that none of our machines will ever do the same thing twice. They always build a new building component with a new set of instructions. So we have to make that connection between the design data flow and the manufacturing data flow. It has to be just one big data flow. And of course, we have to design the manufacturing environment to accommodate that flexibility, right? So, for example, we prefabricate the facade panels out of mass timber. I have a mass timber base, and they're put together out of smaller pieces, and then we put in the windows all with industrial robots, and then insulation, cladding, and all of these things, all of these layers that go together. But where the windows are and how big the panel is really doesn't matter. I mean, there is, of course, a minimum and maximum size, but between that, it can be anything. So all our instructions, all the robot instructions, the shop drawings, fabrication drawings, they're all generated automatically based on that design. So there's a lot of software development behind that. But ultimately, it allows us to really accommodate that level of flexibility that is required. So the realization that we need parametric design and a flexible manufacturing process, that was something that sort of happened 5 to 10 years ago, maybe 15 years ago, when all of these technologies matured. Lots of people in academia played around with them and experimented and showcased what's possible, but sort of to make that transition into serious manufacturing, that took a pretty long time. And I think we are at a point where that's possible. So I wouldn't be surprised if there'd be other companies out there that are trying the same thing. I think we need that. We need a lot of companies that experiment with productization, industrialization, and sort of that level of hyper customization as well. Because of course, there's just so much housing we need to build. Our company couldn't possibly do that. But I think that is sort of the fundamental necessity, and it's based on a thinking of systematization, or a thinking of, here are the systems and rules we need to put in place in order to execute on, and then we need that software and we need that manufacturing technology to execute it.
Wow, I love this. This is so fascinating. Thank you so much for telling us so much about it. I think that it's really been just a great showcase of looking at a business that is a little bit different, that is unconventional, very innovative, but actually being able to have a look into your business mind as well, and justification of all the different parts of the components and approaches, as well as manufacturing processes and design processes. And it's fascinating. So thank you so much, actually, for joining and telling us so much about the business. If we wanted to check out the portfolio and look at the website, where do we find you?
You can find us on the intelligent-city.com. And I think if you search for that on Twitter, Instagram, Facebook, you'll find us as well.
Wonderful. That's excellent. Thank you so much. Thank you, Oliver, for joining. And thank you for everyone who listened in. And we'll see you at the next one.
Thank you so much.